hierarchical clustering, when we do hierarchical clustering, we understood that it is a nested clustering, wherein different clusters are created and it goes as a nested because the values with least distance, it binds together, then it goes in a form of tree-like structure, which is called as dendrogram. So when we are doing hierarchical clustering, it is also done on numerical values only. So we are taking 3 columns: age, annual income, and spending score. And also we know that hierarchical clustering is better when the data set is small. So I am taking only 10 values, only 10 records here for analysis. You can do it on your whole data set also, but you should understand it with small data set first. So let's just subset our data set. Let me show you how it looks like. So this is the data set that we are using. There are 10 rows and 3 columns. Now let's scale this. So whenever you are doing hierarchical clustering, you should scale your data set in order to create good structure of your dendrogram. So using scale function, we will scale this data. If you want to check how it looks like, so it is data. So this is our structure now. This is our data set. The average age is 28, average annual income is $17,000, and spending score is 49.4. Now you can see each of the attributes, each of the variable, it is in the same scale. Now the next step is very important to understand when we are doing hierarchical structuring. Hierarchical clustering, it uses the distance method. We need to calculate distance of each of the clusters. So for that, the function is dist, which helps you to find out the distance. Now, if you remember, we have done the similarities between two clusters. We read about this. So when we use the single linkage algorithm, so it finds out the shortest distance in the both of the clusters, or any cluster, that how many clusters you are using, it will find the shortest distance. When you are using complete linkage algorithm, it will calculate the longest distance between the clusters. If you are using average linkage, so each of the points of each clusters, the distance will be calculated between each of the points. And when you are using the centroid method, distance between centroids, so the distance will be calculated for the centers of each point. Now let's go to R and create, let's first calculate the distance. So it is also called as distance matrix. Let's print this. So these are what happens, like the first value, it will be compared to the second value. So, and distance will be calculated between those points. Then the second value will be compared to the third value. First value will be compared to all the values. Then second value will be compared to the remaining values. So this is how our distance matrix looks like. Now you can see our first point, it is and second point, the distance between these 2 points is 1.2059. Then the distance between 1 and 3 is 1.157. So you can see the distance between 1 and 3 is less than distance between 1 and 2. So if we create a dendrogram, 1 and 3 point, the observation 1 and 3, it will be grouped together. So this is how a dendrogram is created. Points that have least distance between them, they will be first bundled together, then it will be creating a tree-like structure. So let's go ahead and create the hierarchical cluster. For that, the function is hclust. So it will create hierarchical clustering. Within the bracket, give the dataset name. So I am using here the scaled dataset. So remember to use the dataset that is scaled, and then we'll say plot hc, that is the hclust function. So you can see this is the cluster dendrogram that we have got from our dataset. You can see the matrix here, distance matrix, and this is its dendrogram. Now let's understand it. So you can see 1 and 3, as I have told you, the distance between 1 and 3 is less than 1 and 2. So if I take 1, so 1 and 3 are the closest one. So they have been clubbed together. So these are the initial clubs. You can say initial clusters. Then you can compare 4 and 6. So 4 and 6. So it has the least distance. So they have been clubbed together. Now So this is our first clusters that are nearest to each other. Now if we are take 2 and 4 6, so how this cluster is created? So we have talked about two types of hierarchical clustering. So there is agglomerative and divisive. So if we take agglomerative, it goes down to top. So starting from bottom one, the clusters will be created and will go to top to one cluster. So let's go like that first. Let's go in agglomerative way. Now you can check, like it is said, we can see 2 is more near to the group, that is 4 and 6. So how do we compare it? Why isn't it near 1 and 3? Let's check it. So 2, if we compare it with 3, okay, so we are comparing it with 3, so the distance is 2.24. And if I compare it with 1, it is 1.20. Okay, but if I check it with 4, so 2 and 4, so this is the value, it is 0.69. It is a very less distance. Then if I compare it with 2 and 6, the value is 1.35. So you can see this cluster we have already created 4 and 6. So 2 is much more near to this value. So the next cluster that have been created is 2 with 4 and 6 cluster. Now this is one cluster here. At this level, this was the cluster. Once 2 is connected with this cluster, so it became one cluster now. Now it goes ahead when we, depending upon the distance, it connects this cluster and this whole cluster. So this is how it is a nested cluster. It ends when there only one cluster is left with us. So this is how you can check the tree-like structure that we were talking about. Now, once we have created dendrogram, it's time to get clusters out of it. So if you want to cut it into two groups, so the function that we use is cut tree. Okay, it's cut tree, and within the bracket you give the name of the variable wherein you have saved your function, your hierarchical clustering function. And here k means the number of clusters. So I want 2 clusters out of it. So let's see what happens. So there will be no change in the graph because we have not plotted it. We have only cut the function, the clusters, these groups, we have just cut it and saved it in subgroups. Now let's just use table command to check the values. Now these two clusters, first clusters contain 9 values, 9 observations, and second cluster contains only 1 value. So what does it mean? When we cut it into 2, okay, if you can see in the graph, so here one value is entirely single value, and here these are 9 values. So all these 9 values clubbed together, it becomes one cluster, and this is the second cluster. Okay, if you can make out from this table, this is the structure of that dendrogram. It is the second cluster and this is the first cluster, wherein 9 values are available in first cluster and 1 value is available in second cluster. Now let's move ahead. Now what we can do is, when we do not mention anything in our function, we have used hclust here, but we have not given the method, like how the distance should be calculated. So here it defaults take it as average.